So we're going to continue on Unit 1, Lesson 1, Atomic Structure. Yeah, we stopped yeah. So we spoke about orbitals, kind of orbitals. That is, this is types of orbitals. We spoke about S, P, D, F, G, H. We are going to stop at F because the periodic table stops at F. We're going to see that here now. When we see the states of in the atom, there is a lot of levels. This is what we spoke about Bohr's model, which we spoke about the levels, n equal 1, n equal 2, etc. This theory, we said it is correct, but not for a trajectory, for orbits, but for orbitals and for states. So when we see the orbitals, we see that for some energy, for some energy, so we are here. So for some energy, for some levels, there is associated with orbitals. For example, so I'm going to go to another one. This one we finish it. I'm going to go now to another table. If I have an energy or level, I'm going to write it here, level n, level n. Here, number of orbitals, for each level, and I have the list of orbitals. The list of orbitals. For example, on the level 1, what does it mean? It is the lowest energy. How many orbitals I have? Only one. What kind of orbitals? 1s. I have a room, because we said s is a room. If I have higher energy, so I will be in the level 2. I'm going to tell you, like here, I have n equal 1. You see it here. That's what does it mean, level 1. Here it's with orbit, but the logic stands. Why it stands? It stands because only we are going to change the circles. The circles now doesn't represent a trajectory, but it represents levels. That's why when you do the Rutherford model, distribution of electrons in grade 9, grade 10, you did them with like this ones with circles. But the circles now are standing not for trajectory, but for the level of energy. This is level of energy, or the state. The level of energy. So we have level n equal 1, n equal 2, n equal 3, n equal, etc. So this is what it said. If I am in the level 1, I have only one orbital, a room, and 1s. How many electrons I can have here? Only one. Or only 2. Number of electrons. I'm going to put here number of electrons if you want. Number of electrons. Only 2 here. If I am in level 2, it will be 2 power 2 equal 4. This is the rule. The number of orbitals, it is 2 power 2 equal 4. What are these orbitals? 2s, 2p. Why you put here 2? To say this is level 2, and the orbital, it is a room. It is of kind of type s. This one, we are in level 2, but the orbital, it is of kind p. You see here, so I have enough money. I'm going to purchase a room, orbital, or a house like S and P. Now, if I am in the level 3, in the level 3, it will be 3 power 2. It will be 9. So what are these orbitals? These orbitals are of kind 3s, 3p, and 3d. If I am in the level 4, how many orbitals? It will be 4 power 2. It will be 16. What kind of orbitals I will have? I will have 4s, 4p, 4d, 4f. Okay. If I have 5, I will have also 16, because it is the maximum of orbitals. If I have 5, we're going to know why. 5. And what I will have here, I will have 4s, 4p, 4d, 5. I am on level 5. It will be 5s. It will be 5s, 5p, 5d, 5f. If I have 6, it will be 16, and I will have 6s, 6p, 6d, 6f. If I have 7, I will have always 16, and I will have 7s, the kind, 7p, 7d, 7f. This is the orbitals. You can count how many electrons you can put, but I'm going to do them here. Okay. Each orbital can put 2. For example, here it will be 8, because 4 times 2 it will be 8, because I have, for example, 4 orbitals, so 4 rooms. Each room can hold 2, so I'm going to multiply by 2. Here it will be 18. Here it will be 32, and then we have 32, 32, 32. Okay. So this is the orbitals, and this is the levels. So how many levels? I have 7 in the periodic table, and this is the orbitals. Now what we are going to do, we are going to see how the electrons are distributed, for example, in an atom. Fill in energy levels diagrams. So I'm going to go here. I'm going to here. This is the periodic table. This is the block S. So all the ones that are here, alkaline and earth alkaline, all have block S. This one are in block D. This one are in block P. This one are in block F. This is the periodic table. If you recall, this is the periodic table. We are going to understand why it is this one S, this one it is D, this one it is P, and this one it is F. Okay, we're going to understand that. Now, fill in energy levels diagrams. Fill in energy level diagram. So how going to fill it? First, for example, I'm going to, what is the energy diagram for the hydrogen? Example 1, the hydrogen. The hydrogen has how many electrons? 1 electron. It will be like this one. Which orbital? Because it has only 1 electron, it has only 1 level. It will be what? It will be like this one here, 1s. Now the helium. Example 2. The helium, how many electrons he has? He has 2 electrons. Okay. So where I'm going to put these 2 electrons, I'm going to put them where? Always we use the cheapest. The cheapest I see I have, for example, the cheapest, it is 1s because it has a small energy. I'm going to see if it will hold them or not. Yeah, 2 electrons can be put in 1 room. So for the helium, for example, it will be like that. Like this one. For lithium, and this one it is 2s, 1s, and we put 1s like this one. For lithium 3, it has 3 electrons. So what we are going to do, we have to put 2 electrons in lower level, and we have to put 1 electron in higher level, 2s, and we're going to put 1 electron here. See that I put one with arrow up, another with arrow down. Why? Because these 2 electrons are not the same. They have a different spin. You remember the spin? We speak of the electron has a spin that it's spin altered. So we have spin that is positive, 1/2, and spin that it is negative, -1/2. So 2 electrons to be in 1 room, one must be positive, another one must be negative. You can't have 2 electrons up, for example, or down. No. In the room, there is one up and another one down. If one electron it is not, if one it is up, the other one must be down. If one it is down, the other one must be up. So now the question, how we're going to fill the electrons? Why I did 1s? Why I did here 1s and 2s? What rules I followed? So there is a rule, and we are going to go to the rule now. Rule for filling the electrons. Rules for filling the electrons. The filling energy levels. Filling energy levels. Energy levels. Okay, so what is this rule? It shows us it shows what is the order. So how we're going to show the order? We're going to write it here. We have the first order, it is 1s. The second level, if you recall, it is 2s to p. Level 1, level 2. You can go back to the table that we did. Not this table, but this table here. 1s, 2s to p, 3s, 3p, 3d, 4s, 4p, 4p, 4d, 4f, etc. And then we have 3s, 3p, 3d. 4s, 4p, 4d, 4f. 5s, 5p, 5d, 5f. 6s, 6p, 6d, 6f. 7s, 7p, 7d, 7f. This is the, and recall, what orbital, how many electrons it can be? S can hold how many? 2 electrons. P can hold how many electrons? 6 electrons. D can hold 14 electrons. F can hold 10. This one 10, this one 14 electrons. Again, go back to the table that we did. This one here. S can hold 2 electrons. 2%. P can hold 6. D can hold 14. 10. F can hold 14. These ones we have to ignore them because they are not in the program. We are going to ignore them. So you have to know each orbit, how many electrons it can hold, how many orbitals, and how many electrons it can hold. Okay, number of orbitals times 2, it will give you how many electrons it can hold. Here. Good. So now we have to put some arrows. How the arrows we are going to do them? You give me the order. So we're going to put them like that. I have the first arrow like this one, diagonally. And this one like that. 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 And I have these arrows here and these arrows here. These ones are arrows. Arrows. It will show me how to start. The order. You see what I did? I have this one here alone, this one alone, and I have these two here, these two here, these 2, 3, etc. Repeats how to fill this, how to graph this diagram here. This is the diagram, the diagonal rule. We call it the diagonal rule. The diagonal rule for orbital order. Orbital order. We call it the diagonal rule. So what does the rule tell me? Tell me you have to start with this one here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how it's working. Now I'm going to show you how it is working. It is depending on the number of electrons. So once we graph or we sketch the diagram, the diagonal rule, it is easy. Now I'm going to fill for the electron, for the hydrogen. For the hydrogen, how many electrons he has? One electron. So one electron, I'm going to go to this one. I'm going to start with one s. So I have one s. How many electrons I have? I have one. How many electrons I am allowed to put? I have to put two, but I have only one. So I'm going to put one s1 because I am allowed to put two, but I have only one. Now I'm going to go to helium. How many electrons has the helium? Two electrons. Now for the helium, I'm going to start by the one. The one tell me fill out first the one s. I'm going to fill one s. How many electrons I am allowed to put? Two electrons. How many electrons I have? Two. So it will be one s2. That's why if you go, it shows only one s and one s. And this one we can put it with the diagram. I put electron up because I use only one, and this one I'm going to put electron one up and one down. I'm going to put now the lithium. How many electrons has the lithium? 3 electrons. So the rule tell me what? They tell me you have to start by the first, the lower energy, 1s. I'm going to start by 1s. How many electrons I am allowed to put in 1s? I am allowed to put 2. I have 3, so I have to put 2 because I can't put more. I have 1 left, so I have to go to 2. 2, what they tell me? Once you finish it with the diagonal 1, go to diagonal 2. The diagonal 2, it is 2s. So I'm going to put 2s. How many electrons I am allowed to put in the s2? But how many left? 1. Don't put. So I put 1. In the total, 2 plus 1 will give me 3. You see here 2, it is 2, 1, it is 1. Now we're going to go to more complicated. We're going to go to the more complicated. Say I want to do, which one? This one here, I'm going to do which one? Atomic number 14. Which one number 14? I'm going to give number 14. Who has 14 electrons? Yeah, going to, or chlorine. Chlorine has 19. Chlorine. I'm going to for chlorine. He has 19 electrons. Chlorine, 19 electrons. So I'm going to do that again, following the rules. The first thing the rule tell me starts by the diagonal 1. The diagonal 1, it is what? 1s. I'm going to put 1s. How many electrons I am allowed to put? Only 2. But I have 19, so I have to put the 2. Now I finish it with diagonal 1. I have to go to diagonal 2. Diagonal 2, you tell me, fill the 2s, the next orbitals. 2s, how many electrons I am allowed to? Because it is an s, it has only 2 electrons, I have to put 2 here. Now I finish it with the diagonal 2. They told me, go to diagonal 3. Diagonal 3, I have to started by 2p. So I'm going to put 2p. But how many electrons I am allowed to put on 2p? On p, it is I can put 6. I am going to put 6. How many electrons until now? I put 2 plus 2, 4 plus 6, 10. Okay. And now I have to go to S. How many electrons? So once I did the 2p, I have to do the 3s. How many electrons I can put in 3s? S, it is an orbital, it is a room. So I am allowed only to put 2. I have to put 2. So how many electrons did I catch it? 19 or not? I have to count. 2 plus 2, 4 plus 6, 10 plus 2, 12. No. So I finish it with the diagonal 3. I have to go to diagonal 4. 4, they tell me try 3p. How many electrons I can put in 3p? I can put 6 because it is it is a p orbital, so I'm going to have 6 here. I'm going to make a count again. 2 plus 2, it is 4, plus 6, it is 10, plus 2, it is 12, plus 6, it is 18. So how many electrons left? 1 electron because I am at 19. In the diagonal 4, they told me after you did 3p, do 4s. I'm going to do 4s. There is a problem here. I made a mistake somewhere. I'm going to count. I have 2 plus 2. Chlorine has 17, not 19. Has 17 electrons. Yeah, has 17. Mistake. It is 17. It is 17. Chlorine has 17. So I'm not going to put here because I finish it here, but here I can't put 6 here because it will be 18. I have only 17. So what I have to put? I have to put 5 because P can hold 6, but only 5 are left to put. So I'm going to put them on the P. So I'm going to make a calculation again. 2 plus 2, it is 4, 10, 12, and I have 5. It is 17. This is the chlorine diagram. Now we're going to do one that it is big. Let's show you how. We're going to do tungsten, W. We're going to do, and we stop because you will understand how to fill everything. Tungsten. Tungsten. W. And how many electrons it has? 74. So we have to go until 74. Okay. This one here, it is 10 electrons. Tungsten. So what they are telling me, the W, first I have to fill the first 1s. How many electrons I have to put? 2 electrons, because I have to start with the first diagonal. Now I have to go to the second diagonal, 2s. Again, s can hold only 2. I am far from 74, so I have to go to the third diagonal. I have to start by 2p, but p can hold 6 electrons. I have to put 6. And s and 3s. How many electrons can hold 3s? 2 electrons. Now I have to go to the diagonal 4 with 3p. P can hold how many? 6. I am far from 74. So after 3p, I have to go to the 4s. Because s can hold only 2 electrons, I have to put 2 electrons. I finish it with the diagonal 4, fifth now. And the fifth starts by 3d. 3d, how many d? Hold 10. So I'm going to put 10 here. So I'm going to count to see if I catch it, how many catch it. I have 2, 4, 10, 12, 18, 20, 30. I did 30. So I did 3D. And after 3D, the diagonal 5 told me you have to go to 4P. But P can hold 6. And then they told me go to 5S. 5S. And S can hold 2. So 5S can hold 2. So I was at 13. Now I added 8. So the fifth diagonal is finished. I'm going to 6th diagonal. They tell me go to the 4D. So I'm going to go 4D. How many electrons I have to put in the 4D? 10 electrons, because D can hold 10. 10 electrons. And then after 4D, I have to go 5P. 5P, I have to go to 6. And then I have to go to 6S. 2. How much here? It was 30. 30, 38, 48, 54, 56. So I finish it with 6S. I have to go to diagonal 7. And I will have 4F. But the F can hold 14 electrons. And for F, 5D. D can hold 10. So I'm going to stop here and do the calculation. Here I was at 30, 38, 48, 54, 56. So 56, 56, 56, 64, 70 here. So 70, there are only 4 left. So I can't put 10 here because it will be too much. So I have to put 4 here. This is the energy levels of the tungsten. So you understand what I am saying. and I stop here how to fill. And in the next video we are going to do the energy levels. These ones, they are the electronic configurations. These ones are electronic configurations. Instead of energy levels, you write here electronic configurations. We didn't do the energy levels, we did electronic configuration. Fill in electronic configuration, electronic configuration. It is electronic configuration that we did. Okay, that's it. Okay.